This is the Excel sheet that has the same data I just showed on those two tables. You can see here's the group 1, 2, 3, the averages here, and the averages here for the other condition in which the null hypothesis is false. Here I've calculated, there we go, there's quite a delay there. This is where I've calculated the standard deviation squared. Okay, so this is the variance. You can see here's the formula, STDV.S, and then just squaring it at the end. Okay, these are the averages. So you can see they're the same in both of them, even though the averages are different. And this also turns out to be the same. This is just the average of B13 through D13, so the average of these three. And here it's the same. Okay, so the average of those three is going to get you that. Now that is the mean squared within groups, or the mean squared error. Okay, and here is the standard deviation for these three numbers, okay, these three sample means squared. So this is the variance of the sample means across the three groups. Okay, so this is 1, and then to get this MS between groups, you multiply this by the sample size, which in this case is equal across all of them, so it's multiplied by 9, okay? 14 times 9. Here we've calculated this the same, and we've calculated this the same way too. Okay, so this is just the standard deviation of these three numbers squared, so that's the variance, and then you multiply it by 9. So this, of course, is a very different number, so these are going to be very different. Okay, so here is the output from an ANOVA that I ran in Excel. And you can see these numbers lining up here. Here's the variance, 10, 10, 7.5. And then here is between groups, the 9, and here's the within groups, the 9.25. Now this is kind of a teaser for next time. This is called an F statistic, okay? Which in this case is 0.973, etc. Okay, now this F statistic, let me show you how this is calculated. Doing equals here, 9 divided by this one. Okay, and it should convert to, hopefully it'll just convert to, there we go, standard notation, okay? So you can see this is the same number here. So this is just calculated as a ratio between these two things. Now remember, if these are relatively equal to each other, if this is close to 1, then there's not going to be much evidence against the null hypothesis. Mathematically, it works out that both of these will give you a good estimate of the population variance if the null hypothesis is not true. Okay, and if the null hypothesis is true, excuse me. Okay, so if the null hypothesis is not true, then this one will still give you a good estimate, but this one will not. Okay, so this 9 is going to be much bigger than between group variation. Okay, and that makes sense that the between group variation is going to be much larger if the null hypothesis is false, because the means are going to be different. Okay, so the between group variance is going to be bigger. Okay, so the ratio between the two is going to be further from 1, and that will actually give you a lower p-value, which leads you to reject the null hypothesis. In this case, I've ran this on this data here, and the null hypothesis is true, and so this is not very different from 1, and so the p-value is pretty high, not sufficient evidence to reject the null hypothesis. Okay, so I hope that helps to reinforce this concept of MS error, or MS within, and then MS between, or MS group.